Imagine a world so blisteringly hot that the oceans feel like vast, steaming hot tubs. The continents are fused together in a single massive landmass known as Pangaea, stretching from pole to pole. The air is thick with carbon dioxide, released in massive quantities by relentless volcanic eruptions. This is Earth, 250 million years ago, at the dawn of the Triassic period. Following the devastation of the Permian extinction, the most catastrophic mass extinction event in Earth's history, the planet is slowly recovering. Life struggles to re-establish itself, dominated by hardy reptiles and the ancestors of early mammals. The land is dry, barren, and inhospitable. But then, around 234 million years ago, something remarkable happens. The skies darken, the winds shift, and the long-awaited rains arrive. And they don't just come and go, they stay, drenching the world in an unrelenting downpour for 2 million years. This dramatic climatic shift, known as the Carnian Pluvial episode, CPE, reshapes ecosystems, extinguishes dominant species, and, most importantly, sets the stage for the rise of the dinosaurs. The evidence for the extreme dryness of early Triassic Earth lies beneath our feet. Geological records from this period are rich in red sandstones and parched soil layers, indicative of an arid environment. Unlike the swampy coal forests of the Permian, this world lacks widespread wetlands and lakes. One of the primary reasons for this dryness is the geography of Pangaea itself. With the continents tightly clustered together, rain clouds struggle to move inland from the coasts, leaving much of the interior scorched and lifeless. In this unforgiving climate, a variety of creatures thrive. While early dinosaurs are present, they are not yet dominant. Instead, the world is ruled by crurotarsans, a broad group of reptilian predators akin to modern crocodiles. Among them is Ornithosuchus, a terrifying creature capable of briefly standing on its hind legs to chase down prey. Herbivorous rhynchosaurs, stout lizard-like animals with parrot-like beaks, graze on the low-lying vegetation. Meanwhile, dicynodonts, distant relatives of mammals, roam the land in vast numbers, their tusked faces and beak-like mouths giving them a bizarre appearance. Despite their success, these creatures are adapted to a dry world, one that is about to be completely transformed. Most of what we know about ancient climates comes from the study of rocks and fossilized plants. In the early 1990s, two British geologists uncovered evidence that did not align with the expected dry conditions of the Triassic. Instead of arid desert deposits, they found thick layers of river sediments, traces of ancient lakes, and remnants of coal swamps, all clear indicators of a prolonged period of intense rainfall. Further studies revealed that this wet phase was not limited to one region. Similar deposits were found across Europe, the Americas, and even the Middle East. The conclusion was inescapable. The entire planet had undergone a dramatic climatic shift. Initially, many scientists dismissed the idea. Couldn't these findings simply be the result of localized floods? But as more and more evidence surfaced, coal deposits in Austria, lake sediments in Italy, wet soils in Utah, and enormous river systems in China, the picture became clear. Between 232 and 234 million years ago, Earth entered a period of relentless global-scale rainfall. During this time, the annual precipitation in what is now Utah nearly quadrupled, reaching an astonishing 55 inches per year, comparable to modern-day temperate rainforests. These torrential rains weren't the result of a single catastrophic event, but rather a continuous cycle of flooding year after year for 2 million years. With such drastic changes to the environment, life was forced to adapt or perish. One of the most significant shifts was the rapid expansion of dinosaurs. Fossil evidence from this period tells a clear story. At the start of the Carnian Pluvial episode, dinosaurs make up a mere 5% of terrestrial vertebrate fossils. By the Eat-Saisa end, they account for more than 90%. But why did dinosaurs thrive while their competitors dwindled? The answer likely lies in the transformation of plant life. With an increase in rainfall, large conifers and towering coal-forming plants like bennettitails began to flourish. For herbivores, this shift was a major challenge. Short-legged rhynchosaurs, which had once dominated the landscape, struggled to reach the higher foliage. Dicynodonts, which lacked teeth and relied on soft plants like ferns, found themselves increasingly unable to process the tougher, woodier vegetation of the new environment. In contrast, many plant-eating dinosaurs were well-equipped for the change. Some had both teeth and gastroliths, stones swallowed to help grind up food, allowing them to digest fibrous plants that other herbivores couldn't. Fossilized dinosaur dung from this time contains up to 85% wood, a clear sign that they had adapted to eating the tough new vegetation. As the herbivorous rhynchosaurs and dicynodonts declined, so too did the crurotarsans that preyed upon them. With their competitors vanishing, dinosaurs found themselves in a world with little opposition, and they seized the opportunity to dominate. But what triggered this 2-million-year rainstorm in the first place? The answer lies in a cataclysmic event that occurred just before the downpours began: the Wrangellian eruptions. Around 235 million years ago, a massive volcanic region in what is now Alaska and British Columbia erupted with unprecedented intensity. Over 5 million years, these eruptions blanketed the landscape with lava layers up to 6 kilometers thick, releasing enormous amounts of carbon dioxide into the atmosphere. The result was a dramatic rise in global temperatures by anywhere between 3 to 10 degrees Celsius. Warmer temperatures accelerate the water cycle, increasing evaporation rates and atmospheric moisture. Over time, this process led to the heavy, sustained rainfall of the Carnian Pluvial episode. Some scientists even refer to this period as the Carnian humid episode, though one of the more whimsical names proposed is the wet intermezzo, a fitting title for this bizarre chapter in Earth's history. After 2 million years, the rainfall finally subsided. But how did it stop? The key lies in Earth's natural ability to regulate carbon levels. Over time, excess atmospheric CO2 was gradually absorbed back into the ground through processes like plant growth, rock weathering, and oceanic carbonate formation. As volcanic activity waned, the climate stabilized, and Pangaea returned to its hot, dry state. Though the rains ended, the world had been irrevocably changed. The dominance of dinosaurs had been cemented, and they would continue to rule the planet for the next 150 million years. The forests that had flourished during this time laid the foundation for modern conifers, including the towering pine trees we see today. The Carnian Pluvial episode may have been brief in geological terms, but its impact was profound. In many ways, this ancient, prolonged storm shaped the course of life on Earth, clearing the way for one of the most successful groups of animals ever to walk the planet, the dinosaurs. If you found this journey through prehistoric Earth fascinating, don't forget to subscribe for more insights into the natural history of our planet. Have a topic you'd like to explore? Leave your suggestions in the comments. We'd love to hear from you.